All right, guys, so let's take a look at the alkene aspect now of hydrocarbons. So here, alkenes are hydrocarbons that contain at least one double bond. Now, once you start adding double bonds, which are pi bonds, you become unsaturated. Unsaturated just refers to the carbons not having the maximum amount of hydrogens possible. Here, the double bonded carbons are connected to 3 electron groups, so those double bonded carbons have an sp2 hybridization. And now here, what we need to realize is, if we take a look at ethene was those 2 carbons, each one connected to 3 hydrogens. Notice the difference between them. In the alkane version, both carbons have 3 hydrogens. But once we create that double bond, what happens? We lose 2 hydrogens as a result. Why? Because here, those carbons can't be allowed to continue having 3 hydrogens each. Because then if we take a look at this carbon, it's making 1, 2, 3, 4, 5 bonds. Carbon cannot make more than 4 bonds. So the trade-off is this. If you lay down an extra bond, you have to give up a hydrogen. And since we're laying down an extra bond between these 2 carbons, they each have to give up 1 hydrogen. So here, same thing here. It should have had an H here, and actually it shouldn't have this H here at all. So make sure you do a correction of this. There shouldn't be an H there at all, because that carbon is making 5 bonds. So we remove that H there. So I'll make sure to correct that on the PDF, guys, but make sure that you realize right now that that carbon should not have 2 hydrogens on it. It should only have 1. So let's think about this. We're going to say here that the formula for an alkane is CnH2n plus 2. But when we put down a double bond, we lose 2 hydrogens. So what would the formula of an alkene be? Well, we lose 2 H's, so that 2 wouldn't be there anymore. So the generic formula for an alkene with only 1 double bond would be CnH2n. So again, this is the generic formula for an alkene with only 1 double bond. But it also represents the formula for a cycloalkane. Because here, if we think about it, this cycloalkane, if we look, has 6 carbons in it. Remember, every end, every corner is a carbon. Each one we see making 2 bonds, so each carbon has 2 hydrogens we don't see. So the formula of this thing would be C6H12. It has the same exact formula as an alkene, a compound with only 1 double bond. Why? Because the alkane form should have been C6H2 times 6 plus 2. So that would have been C6H14. What's the difference? We lost 2 hydrogens in order to make a ring. So when you make a double bond, you have to give up 2 hydrogens. And when you make a ring, you have to give up 2 hydrogens. That's why they have similar formulas. Here, this is just the basics in terms of identifying the formulas for an alkene and a cycloalkane. When you move on to organic, and I'm saying that a lot, you're going to get more and more complex types of molecules. We'll see a few today, but just realize they get more and more complex. Now that we've seen this, let's see if you guys can try to answer this question here. So I just need the formula and the simplest possible name of a hydrocarbon that contains 1 double bond and 6 carbons. Attempt this on your own and then come back and see how I best approach it.